The aim of our project is to create a prototype that will be used in situations where rescue operations are difficult, and the hero that we need is an unmanned autonomous vehicle. We use the 5-step design thinking process as a guide to design our prototype. The 5 steps of design thinking are empathize, define, ideate, prototype, and test. Step 1. Empathize. In empathize, we understand our target audience requirements so that the final design caters to their needs. This can be done through interviews, camera studies, and simulations. Step 2. Define. The robot has to have the capability to navigate through rough terrain as it will be deployed in areas that are uneven. The robot should be friendly looking and should not scare the victims when it gets close. There should be flexibility to add more accessories to the robot for future challenges and missions. And also, it has to have the ability to communicate with the responders so that the responders know that the robot is still working. As part of the design requirements, the robot is also required to be able to maneuver through the obstacle course shown above. Step 3. Ideate. We initially came up with 3 possible designs. The first design was a car with caterpillar tracks. This was our first design, a car with 4 wheels and caterpillar tracks on both sides. The main power source was batteries, an Arduino Uno, and also 2 ultrasonic sensors to ensure that the car stops exactly 5 cm away from the obstacle, and also 4 motors along with a couple of LED lights. The pros and cons of the design are listed below. We did not proceed with the design as it is hard to solve the cons of this design. Our second design was a vehicle with moving legs. So this is a sketch of our second design. It is a movable robot, a robot with 4 moving legs similar to a humanoid robot. The power source is still the batteries along with an Arduino Uno and 2 ultrasonic sensors to determine the correct stopping distance. The body is of acrylic board. The pros and cons of the design are listed below. We did not proceed with the design as it is hard to solve the cons of this design. And our third design is a 4-wheel driven car. The third design has a rectangular acrylic board on which we have our power source, the batteries, an Arduino Uno, a breadboard for connecting the sensors wires together, and 2 ultrasonic sensors to determine the correct stopping distance, 4 wheels at each corner, and 4 motors. The pros and cons of this design are listed below. We chose this design for our final prototype as it is easy to solve the cons of this design. Step 4. Prototype. For the wheels, we use 4 6.5 cm wheels. For motors, we use 4 motors, 1 for each wheel. For the body, we used an acrylic body as it's light and strong. Power was from the Arduino Uno. The problems we faced were the car did not have enough traction and couldn't clear the hump. The solution we came up with was to attach rubber bands to increase friction and also change the orientation of motors to make them face vertically instead of horizontally to increase ground clearance. The only component change in our second version was that we added rubber bands on the wheels for extra traction. The problem that we faced in this trial was the car did not have enough torque to clear the hump. The solution we came up with was to use servo motors for rear wheels to provide higher torque. The components we added in our version 3 were, we added anti-slip mats for extra traction, we added 2 servo motors at the rear wheels, we also used an ultrasonic distance sensor and a motor driver which was used to control the wheel movement. The problem that we faced were, the sensor was not working properly, and also since the sensor was located at the bottom of the vehicle, occasionally when it approaches the ramp, it will detect that it's 5 cm away from the ramp and the prototype would stop. To overcome this, we proposed using 2 sensors to correctly determine the stopping distance. If both the sensors have the same reading, the vehicle will stop, and if both the sensors have different readings, the vehicle will continue to move. The only change we made in the final design of our prototype was that for the power source, we changed it from the Arduino Uno to 1 9-volt battery and 4 1.5-volt batteries. The problems we faced was that the car could not clear the ramp with the added weight of the batteries. The solution was that we connected the batteries in parallel instead of series to lower the internal resistance. Step 5. Test. Our prototype managed to clear the course. Some modifications that can be added in the future are a GPS tracker for location tracking, a more compact interior to store supplies which are of aid to victims, use solar panels and use it to charge the vehicle through solar energy and use it as a backup power source, a battery level indicator to know how much charge is left in the vehicle so that the responders know when to charge the vehicle. Below are some lessons that we learned over the course of this module and during our design of the prototype. This was our project done for EG1311 by Group 1.